Hello, my name is Michelle and my friend Adriana. We're going to make this video tutorial to explain the topic about algebraic expressions and simplify rational expressions. Okay, first of all, we're going to start with algebraic expressions. An algebraic expression is a set of expressions, as the name says, that has numerical and literal quantities. They have operations like multiplications, divisions, powers, sums, subtractions, etc. There are four types of algebraic expressions. The first one is a monomial. Mono means one, so it will be only one term. Binomial, there will be two terms, bi equals 2. Trinomial, there will be three terms, 3 equals 3. And poly, that means more than or more, it will be more than 3 terms. Okay, next we have to know what a degree is. A degree is an exponent, it's the same. In here I wrote, if we have 1 as an exponent, it will be called first degree or linear. If we have a 2 as an exponent, it will be second degree or quadratic. And if we have a 3, it will be third degree or cubic. In this case, if we have a number that's bigger than 3, it will be 4th, 5th, 6th, 7th as a number, and it will be called degree. In this case, it will be 6th degree. And in the last one, we have rational degree, because it is not a whole number. In this case, it's 1/2. Okay, in here we have an example or an exercise. First, we have the algebraic expression, type of expression, coefficient, and degree of the expression. Okay, first of all, we have to solve the type of expression. In here we have 1, 2, and 3 terms. So, if you remember what I said before, 3 equals trinomial. So here we have trinomial. Then it's asking us for the coefficient. In here I wrote not available. Why? Because we have more than one numerical coefficient. We have 6, 34, and 48. So we have 3, not 1. And it's also asking for the degree of the expression. I wrote second degree or quadratic. We take the highest exponent. In here, in this case, it will be 2. Why? Because imagine he will be an imaginary 1. So 2 is bigger than 1. Okay, now I'm going to show you how to simplify an algebraic expression. Terms are the ones that make up the expression, and they can only be simplified if they are like terms. What do I refer with like terms? I refer that they should have the same variable and the same exponent. If they do not have the same, they cannot be simplified. They should stay the same way they are. Okay, here we have another example or exercise about how to simplify an algebraic expression. 4x and 1x. As I said before, they should be like terms to be simplified. I put with the same color the pair. It will be like blue, purple, and pink. First of all, let's start with blue. 4x plus x, it will be easier for you or to not get confused. You can put an imaginary 1. So it will be 4x plus 1x, 5x. Now let's go with the purple. 8y minus 3y, it will be 5y. And then it will be 2z and 6z. You have to add them, so it will be 8z. And here we have the result.
It is my turn to explain. So we have this expression that is 3x elevated to the 6th power plus 39x elevated to the 5th power plus 120x elevated to the 4th power divided by 3x elevated to the 6th power minus 9x elevated to the 5th power minus 120x elevated to the 4th power. The first thing we need to do is to cancel terms. You may think, oh, it's easy. Just cancel 3x elevated to the 6th power or 120x elevated to the 4th power. They appear on the top of the division and on the bottom. And what is left is the result, but that is completely wrong. Remember only to cancel factors, not terms. To solve this equation, we need to find the common factor. In this case, we need to look for a number that can divide all the numerical coefficients. This number is 3. In this equation, x is also a common factor, so we add it to the monomial. Now we need to look for the smallest exponent, because we are gonna subtract it to the rest. The smallest exponent is 4, so our monomial is 3x elevated to the 4th. Now let's substitute. Remember that if the result is 1, it's invisible. Also remember the rule that if an exponent is 0, the answer is 1. This is our result. We just need to cancel and that's it, right? Well, we can simplify more. How? We can make these trinomials into binomials so we can cancel another term. As in the trinomial it is x squared, on the binomial we will have 2x. We can see that both signals are positive, so on the binomial will also be positive. Now we need to look at two numbers that added can form 13 and multiplied can form 40. In this case are 8 and 5. The same happens here. In the trinomial we have x squared, so in the binomial we will have 2x. We can observe that both symbols are negative, and if we remember the laws of symbols, when you multiply, to get a negative result you need to multiply a positive and a negative. So we know that one of the numbers will be negative and the other will be positive. Because of the part of the addition is negative, we can know that the biggest number is negative. In this case, it will be negative 8 and 5. Now we are ready to cancel terms. In this case, we will cancel x plus 5. And finally, we have our result. Our next equation is x elevated to the 5th power plus x elevated to the 3rd power minus x elevated to the 2nd power divided by x elevated to the 5th power minus x elevated to the 2nd power. Again, we will need to find our common factor. Believe it or not, there is a 1 as a coefficient in all of them. It's just that it is invisible. So this is our coefficient in our monomial. Then x is repeated in all of them, so it is part of our monomial. And 2 is our lowest exponent, so our monomial is x elevated to the 2nd power. Now let's make the operation. It will be like this. And finally we can cancel x elevated to the 2. And this is our result. But we can simplify it more, right? This is totally wrong. Remember, only cancel factors and not terms. So this is the final answer.